Now whenever substitutions are taken, the value of limit also changes. Just divide both numerator and denominator, that is term by term division by x. When theta tends to pi by 2 implies x tends to 0. N log m is also equal to logarithm of m to the power of n. Limit x tends to 0 of a power x minus 1 by x is equal to log a to base 0. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous class, we have discussed problems based on theorem number 1 and theorem number 2. Today also I am going to take a few more problems based on theorem 1 and theorem 2. Now let us come to the first problem. So evaluate limit x tends to 0 of x plus 1 to the power of 5 minus 1 divided by x. Suppose if you put x is equal to 1, by putting x is equal to 1, by putting x is equal to 0, by putting x is equal to 0, what happens? This is 0 plus 1 is 1 to the power of 5 is 1 minus 1 divided by 0, again which is an indeterminate form, 0 by 0 form is obtained. So this type of limits can be evaluated by the method of substitution. Let us consider x plus 1 to the power of 5 as y. Let y is equal to x plus 1. So let us consider y is equal to x plus 1. Now whenever substitutions are taken, the value of limit also changes. As I told in the previous classes, whenever the substitutions are taken, the value of limit changes. What is the limit here? When x tends to 0 implies y is equal to x is 0 plus 1 is equal to 1. So y tends to 1. When x tends to 0 implies y tends to 1. So the given limit converts to limit x tends to 0 is converted into y tends to 1. X plus 1 or 1 plus x is nothing but y to the power of 5 minus 1 can also be written as 1 to the power of 5 divided by x. Now what is x from this? This implies y minus 1 is equal to x. So x can be written as y minus 1. Now if you observe carefully, this is of the form, since limit x tends to a of x raised to n minus a raised to n by x minus a is equal to n into a to the power of n minus 1. So here see, x tends to a of x raised to n is equal to, here n is equal to 5 and a is equal to 1. So x tends to a of x raised to n minus a raised to x minus a is equal to n to the power of n minus 1. Limit y tends to 1 of y to the power of 5 minus 1 to the power of 5 divided by y minus 1. N is equal to 5 and a is equal to 1. Substitute here n. 5 into a is 1 to the power of 5 minus 1. 5 into 1 to the power of 4 is 1 itself. 5 into 1 is 5. So the simplified answer for this is 5. So the limit value of this equation is 5. That's it. Very simple. This is how we are going to evaluate by the method of substitution. Now let us come to the next problem. What is the next problem? Evaluate limit x tends to 2 of 1 over x plus 1 by 2 divided by x plus 2. So straight away substitute the value of x. Put x is equal to 2. X is equal to 2. Then this is 1 by 2 plus 1 by 2 divided by 2 plus 2. 1 by 2 plus 1 by 2, half plus half is 1 divided by 2 plus 2 is 4. So the simplified answer for this is 1 by 4 is the value of the limit. Now let us come to the next problem. This is very important problem. Limit x tends to 0 of ax plus x cos x divided by b sin x. Very simple, just convert this into the form sin x by x. Now just divide both numerator and denominator by x, term by term division. So this can be written as limit x tends to 0 of term by term division, ax divided by x plus x cos x divided by x whole divided by b sin x divided by x. Just divide both numerator and denominator, that is term by term division by x in both numerator and denominator. Now cancel the terms which gets cancelled. This can be written as limit x tends to 0 of x gets cancelled, a plus again x and x gets cancelled, cos x. In the numerator we will get a plus cos x, in the denominator b into this is sin x divided by x. Now apply the limit for this. Now if you apply the limit, put a as it is. What is cos x? Cos 0 divided by b is a constant. Since limit extends to 0 of, we know this formula, limit extends to 0 of sin x by x is always equal to 1. So this is equal to 1. A plus, what is cos 0? Since sin 0 0, cos 0 is 1 divided by b into 1 is b. So the simplified answer is a plus 1 divided by b is the answer for this. That's it. Very simple and very important problem indeed. Just divide both numerator and denominator by x, term by term division. Ax by x plus x cos x by x divided by b sin x by x. X and x gets cancelled, x and x gets cancelled. A plus cos x divided by b into sin x by x. Apply the limit, put x is equal to 0. A plus cos 0 divided by b into, since sin x by x is of the form sin theta by theta is equal to 1, when x tends to 0 is 1. So a plus cos 0 is 1 into b into 1. So a plus 1 divided by b is a simplified answer. That's it. Okay. Now let us come to the next problem. Limit x tends to 0 of cos square x divided by 1 minus sin x. Now we know this can also be, if you put x is equal to 0, then what happens? This is sin 0 0, cos 0 is 1. We will get 0 by 0, which is an indeterminate form. So this limit can be written as limit x tends to 0 of cos square x can also be written as 1 minus sin square x. Cos square x is 1 minus sin square x divided by the denominator 1 minus sin x is as it is, since cos square x is also equal to 1 minus sin square x. Now this can also be written as limit x tends to 0 of, if you observe carefully, the numerator is of the form a square minus b square. This can be written as 1 plus sin x into 1 minus sin x whole divided by the denominator is same, 1 minus sin x. So 1 minus sin x, 1 minus sin x gets cancelled. See here, 1 minus sin square x is nothing but 1 plus sin x into 1 minus sin x. 1 into 1 is 1, plus into minus minus, sin into sin is sin square. A square minus b square is a plus b into a minus b. 1 minus sin x gets cancelled. What is left in the numerator is limit x tends to 0 of 1 plus sin x. Now just put x is equal to 0, 1 plus sin 0. So sin 0, 0, 1 plus 0 is equal to 1. The simplified answer for this is 1 is the required answer. Now let us come to the next problem. Limit x tends to 0 of cos x divided by pi minus x. Straight away you can put the value of limit. Here x is equal to 0, put x is equal to 0. Then this reduces to cos 0 divided by pi minus 0. What is cos 0? Sin 0 0, cos 0 is 1 divided by pi minus 0 is pi. So the required answer is 1 by pi is the required answer. That's it. Very simple problem for 1 mark. Now let us come to the next problem. Now limit theta tends to pi by 2 of cos theta divided by pi by 2 minus theta. Here also if you substitute theta is equal to pi by 2, then you will get 0 by 0, which is an indeterminate form. This can be evaluated by the method of substitution. Put pi by 2 minus theta is equal to x. Then just interchange, which implies pi by 2 minus x is equal to theta. Whenever substitutions are taken, the value of limit also changes. When theta tends to pi by 2, implies x is equal to pi by 2 minus theta is pi by 2. So when theta tends to pi by 2, implies x is equal to pi by 2 minus pi by 2 is 0. So therefore x tends to 0. When theta tends to pi by 2, implies x tends to 0. Now the given limit converts to, the given limit can be written as limit theta tends to pi by 2. Theta tends to pi by 2 is converted into x tends to 0 of cos, what is the value of theta? Theta is equal to pi by 2 minus x divided by, in the denominator, pi by 2 minus theta is equal to x. Now if you observe carefully, this is limit x tends to 0 of cos 90 minus theta. Cos 90 minus theta is sin theta divided by x. Since cos of 90 minus theta is equal to sin theta. So, cos pi by 2 minus x is sin x divided by x. You know the standard result, sin theta by theta is 1. Limit extends to 0 of sin x by x is always equal to 1. That's it. Very simple problem, right? See, just convert, let us take pi by 2 minus theta as x, and then pi by 2 minus x is equal to theta. Whenever the substitutions are taken, the value of limit changes. When theta tends to pi by 2 converts to x tends to 0, substitute here, x tends to 0 of cos, what is theta? Theta is nothing but pi by 2 minus x divided by pi by 2 minus theta is equal to x. Cos 90 minus theta is sin theta. So, sin x by x, when limit extends to 0, sin x by x is equal to 1. That is the simplified answer. Hope you followed. Very important problem for 2 marks. Now, let us come to the next problem. Limit extends to pi by 2 of tan 2x divided by x minus pi by 2. Now, if you put x is equal to pi by 2, by putting x is equal to pi by 2, this equation reduces to tan of 2 times x is pi by 2 divided by x is nothing but pi by 2 minus pi by 2. So, denominator pi by 2 minus pi by 2 is 0. Tan 2 gets cancelled, tan 180. What is tan 180? Tan 180 can be written as 180 plus 0 is tan 0. So, sin 0 0, cos 0 is 1, tan 0 is also equal to 0. So, 0 by 0, which is an indeterminate form. So, this can also be evaluated by taking the substitution. Put pi by 2 minus x is equal to theta. Now, put x minus pi by 2 is equal to theta. Put x minus pi by 2 is equal to theta, which implies, now let us take the substitution. Put x minus pi by 2 is equal to theta. This implies x minus theta is also equal to pi by 2. So, whenever substitutions are taken, the value of limit changes. When x tends to pi by 2, implies theta is equal to x is pi by 2 minus pi by 2, that is equal to 0. Now, the given limit, so the given limit can be written as limit x tends to pi by 2 can also be written as theta tends to 0 of tan of 2 times, what is the value of x here? Here x is equal to, so from this we can write x is equal to theta plus pi by 2, theta plus pi by 2, theta plus pi by 2 whole divided by x minus pi by 2 is equal to theta. Now, this can also be written as limit theta tends to 0 of tan of multiply by 2, 2 theta plus 2 and 2 gets cancelled, pi divided by theta. So, this is limit theta tends to 0, this can be written as tan pi plus 2 theta divided by theta. Limit theta tends to 0, tan 180 plus theta. 180 plus theta comes in third quadrant. In third quadrant, tan and cot are positive, and the same trigonometrical ratios will get. So, this can be written as limit theta tends to 0 of tan 180 plus theta is tan theta. Instead of tan theta, it is tan 2 theta divided by 2. Now, just multiply and divide by 2, you will get the answer. So, this can be written as limit theta tends to 0, multiply and divide by 2, 2 into tan 2 theta divided by 2 theta. So, 2 into, again this is of the theorem, tan theta by theta is also equal to 1, 1 into 2 is equal to 2 is the simplified answer. That is it, very simple, right. Now, let us come to the next problem. Next problem is evaluate limit extends to 0 p power x minus 1 by x. This is a 3 marks question. Here, very simple. Actually, if it is for 1 marks, the value of limit extends to 0 p power x minus 1 by x is always equal to 1. If it is for 3 marks, we have to verify step by step. Now, let us consider this as theta or y. Put e to the power of x minus 1 is equal to y. So, whenever substitutions are taken, you know the value of limit also changes. When x tends to 0, implies y is equal to e to the power of 0 minus 1 is 1 minus 1 is equal to 0. So, y tends to 0. Whenever substitutions are taken, the value of limit changes. Now, what happens? This e raised to x minus 1, e raised to x minus 1 is equal to y. From this we can write e to the power of x is equal to y plus 1. Get the value of x from this. Taking log on both sides, logarithm of e to the power of x to base c is equal to the logarithm of y plus 1. So, here this can also be written as x log e to base c is equal to logarithm of y plus 1. Log e to base c is equal to 1. Therefore, x is equal to logarithm of y plus 1. This is the value. So, just take log on both sides and get the value. X is equal to log of y plus 1. Substitute here. So, the given limit can be written as limit x tends to 0 is converted into y tends to 0. E to the power of x minus 1 is nothing but y divided by what is x? X is equal to log of y plus 1 to base c. Now, divide both numerator and denominator by y. Divide by y in both numerator and in denominator. Then we will get limit y tends to 0 of y by y is 1 divided by log of y plus 1 by y can also be written as 1 over y times log of y plus 1. Now, this is of the form. You know one formula is there. N log m is also equal to logarithm of m to the power of n. This can be written as limit y tends to 0 of 1 over n log m. This is nothing but logarithm of 1 plus y to the power of 1 by y. Now, since there is one more formula in limits, since limit y tends to 0 of 1 plus y to the power of 1 over y is always equal to e, an exponent. So, therefore, this can be written as 1 over logarithm of 1 plus y to the power of 1 over y is equal to e. So, 1 over log e to base e is 1. So, the simplified answer is 1 is the answer for this. So, therefore, e to the power of s limit x tends to 0 of e power x minus 1 by x is always equal to e. This is very important derivation formula. If it is for 1 mark, straight away you can write 1. If it is for 3 marks, you have to follow these steps. That's it. Now, let us come to the next problem. Limit x tends to 0 of e to the power of 3x minus 1 by x. Now, very simple problem. Just multiply and divide by, divide and multiply by 3. That is, multiply and divide by 3 in both numerator and denominator. This can be written as limit x tends to 0 of, just multiply by 3, 3 into e power 3x minus 1 divided by 3 into x. Now, you can take 3 out, 3 into limit x tends to 0 of e to the power of 3x minus 1 divided by 3x. Now, this is of the form e raised to x minus 1 divided by x. Since we know e to the limit x tends to 0 of e to the power of x minus 1 by x is always equal to 1. So, this can be written as, this is 3 into 1, that's equal to 3. 3 is the simplified answer. Very simple problem. Just multiply and divide by 3. 3 e to the power of 3x minus 1 divided by 3x. So, just take 3 constant out. 3 into limit x tends to 0 of e power 3x minus 1 divided by 3x. This is of the form e to the power of x minus 1 by x, that's equal to 1. So, 3 into 1 is equal to 3 is the simplified answer. That's it. Hope you followed. Right. Now, let us come to the next problem. Limit x tends to 0 of 3 to the power of x minus 2 to the power of x divided by x. This is also a very simple problem and important problem. Now, let us convert this into the form. We know there is one formula. Limit x tends to 0 of a to the power of x minus 1 by x is always equal to log a to base c. Now, using this formula, convert this to this formula and evaluate it. That's it. Limit x tends to 0 of a power x minus 1 by x is equal to log a to base a. Now, convert this. This limit can be written as limit x tends to 0 of 3 to the power of x minus 1 minus 2 to the power of x minus 1 divided by x. That's it. See here. So, minus 1 minus 2x minus into minus plus, minus 1 plus 1 gets cancelled. We will get 3 power x minus 2 power x by x. Now, this can also be written as limit x tends to 0 of 3 power x, term by term division, 3 power x minus 1 by x into minus limit x tends to 0 of 2 power x minus 1 by x. Term by term divide it and apply the limit 3 to the power of x minus 1 by x, limit x tends to 0 minus limit x tends to 0 of 2 to the power of x minus 1 by x. Now, if you observe carefully, this is of the form a to the power of x minus 1 by x, and limit x tends to 0 is log a to base c. Here, instead of a it is 3, instead of a it is 3. So, this can be written as log of 3, log 3 to base c minus log 2 to base c. Log m minus log n is equal to log m by n. So, the simplified answer is log of 3 by 2 to base c. That's it. So, this is equal to logarithm of 3 by 2 to base c. Very simple and very easiest problem. Convert into the form a power x minus 1 by x. Substitute here a is equal to 3, a is equal to 2. Log 3 minus log 2 is log of 3 by 2. That's it. That's all for today's session. Let us meet with the different concept in the next class. Thank you. Thank you very much.